Hi there, this is Ted M. Young, also known as Jitter Ted on social media. Welcome to the series of episodes where I'm developing the Kid Money Manager application. This is episode 6, Persistence with Postgres, where I continue to work on persisting the account transactions to a database, including using a local Postgres database running in Docker, and then deploying it to Heroku, where it uses Heroku's Postgres database instance. If you find these episodes useful, let me know on Twitter or on my website at tedmyoung.com. Enjoy! Today's plan, so let's go ahead and look at our Trello board, which is not a Kanban board, folks. It is just a task board. If it were a Kanban board, it would have work in progress limits or work in process limits, depending on how you pronounce the P. It does not, and that's okay. Sort of self-limiting. So let's review where we are. So yesterday we deployed the application onto Heroku. That was almost too easy. Basically, all I had to do was add a new app to Heroku, point it at the GitHub repo. So this is the GitHub repo. And we didn't have to do anything additional. There was actually no configuration. Let me refresh because this is no longer private. So it recognized that this was a Maven-based Java-based application. Did the appropriate thing, actually recognized that it was a Spring Boot application. And so what you'll see here is it automatically set the server port to the port that Heroku creates dynamically and knew to run the jar file that was created. So we can go ahead and open the app to see what it looks like. Now, you'll notice, if you can see down here, it's waiting. So let's go back to the dashboard. One thing you'll notice is, see these hexagons with the little Z's? That's because if it's a hobby dyno, basically it will put it to sleep if it's not active. Where's our kid bank? So here's our kid bank. We're basically waking it up. So it's awake, and here's the app. We see when it starts out. So at any point, this app can be basically torn down and restarted. Basically, there are no transactions. We can go ahead and load up some transactions. And if you remember from last time, we can actually load in a bunch of CSV files. I'm going to actually load in all of them. Last I checked, that worked. Yep. So here's all the transactions, and here's the current balance. And so everything looks good there. We can go ahead and do another deposit. We can say, well, somewhere around the holidays, you got $200 as a combined birthday holiday gift. Deposit that. And so now the balance has been updated. So this is the application. So we made the table kind of nice looking. Back to today's goals. So we can view the balance, we can deposit, we can spend money, we can import a CSV, we have minimal styling, and we deploy the app to Heroku. The GitHub repo is now open, so it's basically a Ted Young kid-bank. So what we want to do today is we want to persist transactions. So one of the things we started doing yesterday, let's go to our transaction repository, is that we used the JPA repository interface from Spring Data to automatically do the persistence. And we proved to ourselves that that worked because we started the application. In fact, I can start it locally. And instead of going to the one up on Heroku, we'll go to the local host, which isn't ready yet. There it goes. Okay. Yesterday we had it so that the application loaded up the transactions from the transaction repository. And here we saw with the configuration that if we set this DDL, right, the data description language stuff, right, that creates tables, things like that, if we set it to update, by default, it will drop everything and recreate it, but we set it to update, so that only means changes will affect the database. Otherwise, it leaves it alone. So it should have been reading from here. So the question is, why didn't it do that? So find all should have retrieved all of the entries upon startup, right? Because here we set this to primary. So remember, that means Spring will prefer to use this method to get an instance of an account. And if you recall, account basically gets injected into the account controller right here, right? So it's auto-wired. So when it tries to create the account controller, it needs an instance of an account. And it has two options. It can look at account itself, which is a component, but we wanted it to look at this one, which goes ahead and creates an account, does a find all, and then loads those transactions. So I'm wondering, did we lose the transactions? Let's go ahead and set a breakpoint, and we'll debug this. Because the database file is still here. That's this guy, this txns.mv.database. So, find all, return none. That's weird. Oh well, all right, well, somehow we lost the transactions. I know I was playing around with some of the stuff, so with a transaction repository, so maybe I messed something up. Not sure. So let's do this. Let's run it. Let's go ahead and load in a bunch of transactions, basically the entire set that I've gotten from the spreadsheet. So that's all there. And let's restart the application. That's interesting. So it's not finding. Are we not saving? That's a good question. So in account, well, if the transaction repository is not null, we do save it. Oh, but right. So yeah, so what happened when we did the load, so the bulk load, and I actually have a note about this, basically that's this in this part where if we do a bulk load, we're actually not saving it in the database because we're using the load for two different things. We're using the load to do the initial load from the database when it starts up. We're actually also using the load to load from the CSV, but when we're doing the import from the CSV, we actually want to save that. So yeah, we'll have to figure that out. Let's figure that out now because it's kind of annoying. And previously, when I looked at account, I didn't like the idea that account self-loaded the transactions from the database. But as I mentioned, looked at last time, it already has a reference to the transaction repository, right? Because account is the thing that's responsible for persisting the information. Now, if you're coming new to this, you're saying, what the heck? Why is account doing that? Shouldn't there be some DAO or a repository thing? Yes and no. In a sense, account is this singleton thing. And eventually, once we go to multi-tenant where they're going to have multiple accounts, it'll look a little bit better. But right now, account is responsible for storing that information. So in a sense, it's acting as its own repository for transactions. So let's have this. So when the account starts up, let's take the stuff that we had in here where it loaded the transactions. And so we'll grab this, these two lines, and put those here. Actually, we can just take this and put that in here. So now what will happen is when it starts up, the transaction repository will be injected through the auto wiring. It will do a find all. If find all happens to return an empty list, then load won't do anything, and that's okay. It still doesn't solve the problem that load is being used in two ways. And actually, we don't want to use, there's no reason to use load, right? Because we're not there aren't already going to, when this account gets created, transactions is empty. Right? This is basically an immutable set of empty. And so there's no point in using this builder stuff to add on, whoops. There's no point in using this builder stuff to add to the transactions and transactions to load, right? That kind of is sort of ridiculous. So what we can instead do is actually store the transaction directly. So let's do this. Let's extract this into loaded transactions. Transactions to load. That's a pretty smart name. You know where it got it from? It got it from the parameter name for load. IntelliJ, you amaze me. Okay, so now what we can do is we can say transactions is an immutable equals an immutable set. We need the builder version. So mutable set builder add all of the transactions to load, and then build, and boom. What are we not happy about? Oh, I didn't type it, so transaction. Does it go there or does it go after? I always forget. Yeah, it goes there. Yeah, this is the funky thing about generics. So basically we need to type that this builder is going to be returning things of transaction. So what will happen here is the account will start up, it'll get a reference to the repository, then we're going to load those transactions directly and create an immutable set and assign it to transactions. So now we're no longer going through this load, which means we can now resume using load for the bulk load that we were using from importing the CSV, which means we want to save those transactions. Now, if we look at the save method in our repository, it currently only takes a single one. Now, if I remember correctly, there is a save all that takes an iterable, right? So we can actually pass in a list. We don't need to have this. Basically, we can say transaction and save all transaction. No, not transaction annotation parser, thank you. So it returns a list of S. Oh, I haven't defined S, that's why. That's interesting. Okay. So then let's undo this. So we'll need some of that generic stuff. All right, let's try to override it again. Okay, now that's fine. Before it was not fine, I'm not sure why. So this is kind of funky because of the way stuff is overridden. Let's also fix up how we override save. So let's do that. Save, okay. And find all is, well, that's interesting. There's a find all that takes a sort. That's not what we want though. I don't want any of these actually. Now, we're going to undo a bunch of this stuff because, as I mentioned yesterday, this is supposed to be a port in our hexagonal architecture, meaning that transaction repository should belong to just the domain. It shouldn't have anything other than maybe some innocuous annotations, but it shouldn't have anything that deals with infrastructure like a database. The problem is the minute we bring in this, it's going to bring in a whole bunch of stuff, and we would not be able to create one that would work with pure unit tests. So again, that's something that we're gonna deal with, and that's going to change the way this interface works. But let's leave that for now. The whole point is that we wanted to. I'm using this thing called Luna Display, which is awesome. It's basically this little dongle that I'd show it to you, but then I'd have to unplug it. It's a little dongle that plugs into the Thunderbolt or DisplayPort, and basically transmits screen stuff over to my iPad, and so that way I can actually run OBS, which is the screen broadcasting stuff, and see that on my iPad. And so that's really nice, so I can actually switch scenes and do some other stuff, and it's like a second screen without actually having a second monitor. The problem is I'm already using a lot of my Wi-Fi for transmitting, and so I think it's blanking out on occasion. So we were looking to create, so in our transaction repository, we now have a save all. And so what we want to do is when we have a load, we actually do want to do a save all. So we'll do a transaction repository, save all, and we can hand in those transactions to load, and that will save all of them in the database. So let's restart our application. Oh, and I forgot to turn on my Pomodoro timer because I have a tendency to just keep going until the story's done. Okay, so let's look at, if we refresh this, it should be empty, correct? Let's this in, import it. So that should have saved it all to the database. And so if we restart, when an account gets created, it should load all the transactions from the database. We have all our transactions because they were stored in the database. Cool, okay. So that's good. So actually now that we're doing the loading in here, back in our stuff here, basically the bean creation, since we're not doing anything with it, we can actually just completely delete this and let Spring just instantiate the account, do the auto wiring, and it should just work. Let's just double check that. And the data is there. Cool. Let's go ahead and add that gift. And great, okay. So now we've got the data in our local database. Now is a good time to do a commit. Of course, I should probably run all the tests before I do a commit. Normally I have my pair to remind me of running all the tests. So let's do that. Let's run all tests. So this runs both the integration tests, which will take a little while to run, and the unit tests, which will take no time at all. So most of the time spent here. And it's actually going to take longer now because now it's doing all the database stuff. Which those tests will fail because I had tests there that, because I didn't set up the date. So there's test annotations for the integration tests for testing data, and I haven't done that. And so those tests are going to fail because they assume that there are no transactions in the database. Plus, it didn't even set up the database, so those are not going to work. All right, I'll have to fix that. And null pointer, and this is something we'll fix today. So right here in the unit tests, so if we look at the unit tests, we basically create an account with no transaction repository, right? Because if I'm running it locally, really local is the wrong word. If I'm running a micro test, a unit test, I don't want it to deal with databases, right? So I basically don't have a transaction repository, and therefore that's set to null. And that's why we're getting the null pointer exception here, because I'm trying to do a save all. So I kind of need to wrap this in a if it's not null, and this is really kind of ugly, right? This will definitely take care of, if you're familiar with some of the design patterns, this is a perfect example of what we'd love to do is a null object pattern where we basically have a transaction repository that does a no op for save all, so we don't have to check if it's null. But we're actually going to have a fake one that we'll create, but we'll do that. We'll do that once we figure out the repository interface and separating it from the actual infrastructure implementation. It would help if I pressed Control R to actually run the tests. So I'm going to run the unit tests. Those run really quickly. Those should now all pass, and they do. The integration tests, they fail because I believe I have not set up yet the data JPA, the data JPA, the test data JPA stuff that it needs in order to properly run those. To think about how I want to run those tests. So this one failed because there was a bunch of stuff in the database. Yeah, so this one failed because We were expecting empty because this is the new account has no transactions. We were expecting empty, but we got a whole bunch of transactions. Here, we were expecting a deposit should have had just the one deposit. That's not true because our database is not empty. This one, why is this one failing? The balance is wrong because we've got stuff in the database. So the stuff we need to do there, I'm not going to worry about that right now because we're gonna fix that with more work on our database. So let's see application properties. What's unversioned? Yeah, we want to leave that unversioned. So what we've done since last time is basically added database JPA support for storing transactions. Okay, we definitely want to get to the Postgres stuff, but I think this one is sort of first thing we need to do, which is we need to separate the transaction repository from the JPA implementation. So for to remind folks of the architecture that we're looking at, basically this is the hexagonal architecture. For those of you, you may know it as onion architecture, which is feels like that's slightly different, or clean architecture, whatever that is. Ports and adapters is the other common name for this because that's what we deal with. But I've kind of gone back and forth because hexagons are apparently really stable things in physics. You see them in chemistry as well. So I'm kind of going back and forth with what I refer to it as. So when we're looking at persistence, so let's focus on this stuff here. We're looking at, this is our application domain core, and anything that crosses the boundary is something that should be able to be replaced or unplugged or basically deleted and not affect the application domain core. And so what we're doing is we want to, though, initiate something from our domain, from our application. And again, there are sort of two ways that things happen inside this hexagon. One is they're initiated by outside, right? So like I submitted a form, that causes something to happen. And sorry, I just had a chat come in. I'll actually set aside a few minutes to answer some of those questions. So when things come in from the outside, these are driven because these things on the outside are use cases. And if you don't know what use cases are, they're basically like sort of like user stories, but a bit more expanded. Somebody does something on a phone, somebody does something on a web app, and that initiates something in an adapter. And so that's the first contact with the system is an adapter. And then it does something into the domain. Sometimes, though, things inside the no worries. Sometimes things inside the domain need to be initiated, either as a result of something coming in from an adapter or just maybe something happens on some set time period. And so because we want to keep things in the domain, we can't rely directly on some persistent storage. So we create something inside of our domain that then somewhere else will plug in an implementation. So these ports are generally interfaces. And so what we want is we want an interface that does what we want to do from a persistence standpoint. It doesn't have to implement anything. It doesn't have to, it basically serves our application domain. In our transaction repository, right now we're extending the Spring data stuff, but we don't have to do that, right? We can basically just do this. And we won't want to write anymore, won't do that. We can sort of get rid of this funky generic syntax and be really specific about what do we want this thing to do. And we can even be better about the way we name things here. And so what I'm defining here is this is the interface that we'd like. It has no connection other than maybe the methods look similar to what you might find in the Spring data stuff. But there's no nothing specific here that talks about the implementation, right? So this transaction repository is basically this port right here. We're defining what the application wants to use from this port, and then later on we'll worry about how that actually gets persisted. This is great, except now we don't have an implementation of this, so none of our code will work when we don't actually have it connected to anything. So there are two things we want to do. First, we want to look at from the unit test standpoint. Let's go to, let's say, let's look at our account controller one. So here we've got an import command that we're testing, basically a bunch of comma-separated lines, and we want to make sure that when we do an import, it imports it. But this test, if you see here, account has no repository. And so account controller, when it tries to retrieve the information, basically when the account tries to retrieve the transactions, that will work, but it won't be saved anywhere. Really what we'd like is a fake repository to deal with. Because what we'd really like, and this sort of solves two problems, right? So remember, in account, we were having to do this null check. We don't want to do that anymore. We'd like to get rid of that null check. What we want to do in like our account controller test is basically pass in something that's an implementation of transaction repository. And so we can create a fake one. So fake transaction repository. And so what this will do is we'll go and create a class. Now this fake transaction repository is only for tests. Right? So the only reason we want this is for testing purposes. Because if we're running the application, then Spring is going to create one, or we'll get Spring to create one. And we'll see how to connect that. But this fake one is really for tests. So it doesn't go in our production code. Test route is selected while the sort route is expected. You may think that, but actually no, I want it this way. Thank you very much. So let's go ahead and implement the methods. What we can simply do is create a list of transaction. And normally if I was doing something that I hadn't done a million times before, I would test drive this, but this is, since this is a fake, it's only for tests itself, and it's basically a wrapper around a list, we'll just write it, because this is pure delegation, right? So this fake is purely delegating all of the behavior to the array list, which we assume works. And this one, just return transactions. Oh, this one, transactions dot save dot add. Let's call this to save. Add all transactions to save. Add all cannot be applied to iterable. Oh, okay. So basically add all wants a collection. All we've got is an iterable. Since we get to define this interface, I'm going to define it as list, which means we're going to need to change this. So let's go here, change this to list. Because remember, we get to define this. I took iterable because that was what was defined in JPA, but we're basically pulling apart this, so we get to do whatever is convenient for us. So again, this interface is convenient for the domain, really doesn't matter what else, what the JPA one is doing. That's a Boolean. Transaction. Technically, IDs are supposed to be assigned, but we're not looking up anything by an ID, so we're not going to worry about that right now. And then return transactions. So the typical contract for these is that you return the thing that was saved after IDs were assigned if IDs didn't already exist. So that's our fake. It does really not much of anything other than store the stuff. And so that means in our unit tests, like here, we can instantiate a new fake account repository, and we can do this anywhere that we were previously just not passing in anything. And so if we just run this test, this should still work, and it does. The key is now let's basically take out the null check. And we'll take out the null check from here. And so now running the test, that should still work. And then we'll have to go and change all the other unit tests that use the transaction repository, or that are expecting a transaction repository. And we'll see those with null pointer exceptions. So here, actually an easier way to do it, why didn't I do that before, is let's use IntelliJ to say, hey, delete this thing. We'll delete that, and then we'll find, just when we build it, we'll find out all the places that it didn't work. Would have been nice if there was and maybe there isn't, I'm not aware of it, that sort of a refactoring that said, please replace this constructor with this other thing. Over here. Oops. And here. There's a refactoring I did last time that maybe I should have just done this first, but whatever. And I think that's all of them. Is this one still red? Ah, yes, this one. All right, so now let's run the unit tests. And boom, okay, they all pass. So now, if we go back to our account, so we see we only have one constructor. It takes a transaction repository. We no longer have the no argument one because we don't need it anymore. And we don't have any null checks in here. So that's a big improvement. Well, that's interesting, because now we're always loading from the database. We actually don't need this, so let's go ahead and get rid of that, because that gets replaced during the construction time, so we don't actually need to assign that. So let's do a commit here. We basically created fake transaction repository implementation for tests, implementation for tests, and updated all tests for that. And so we'll commit that. So normally I don't like to do commits where there are failing tests, but right now the failing tests are integration tests, so I'm kind of okay with that. We're just about out of Pomodoro time, so actually this is a good point to take a break. So let me just see where we are. Okay, so we've got our fake repository. We now have our interface, and so now the problem is at runtime, we'll see that Spring is going to complain because it's going to look for an implementation of this, and it's actually not going to find one. It won't find the fake one because the fake one is just a POJO, right? It's just a plain old Java class, has some behavior, but Spring is not aware of it because there's no annotations on it. There are a couple of things we could do. We could say, hey, this is a component, but remember this one was for tests only. So we'll see that we can annotate this one so that Spring will use it, but only use it during tests. What we want is we want to now hook together Spring Data's repository stuff with our domain repository, the port in our ports and adapters. So we implemented a fake transaction repository, so that was great for our unit tests. If we run the application, what will happen? So Spring's going to try and start up. It's going to then go and say, oh, look, I need to create a count. After it does all its hibernate stuff. And it says, hey, no qualifying bean of transaction repository available. Right, because what's happening is Spring is saying, okay, this is a component. I need to go instantiate a count. Great. Okay, what does it need? It's auto-wired a transaction repository. Okay, transaction repository is an interface. Are there any implementations of it? Yes, but Spring is not aware of this one. So I could do @component, which would basically let Spring be aware of it. But remember, this is for tests, not for actual production, so that would be not a good idea. So what we need to do is implement one that uses the Spring Data JPA stuff. So let's go do that. Let's go to transaction repository. We will, oops. So we'll implement the interface. Coding note, if I ever see impl as a class name, I point out that that is not right. That is not what you want to do. Because that just doesn't, I know that's sort of the default, and language and lots of code out there does that, but the whole point of a name of a class is to provide some information about what kind of implementation it is. So this is a JPA transaction repository, which is what we're going to implement. Now, the other thing is we have our packages organized according to where they go in the ports and adapters architecture. So it is, since this has JPA in it, immediately we know this is not what we want to put in our domain, right? Our domain should not care and not have anything to do with concrete specific implementations, right? To go back to the picture, we're in our domain. Domain stuff is only domain stuff, never deals with stuff. So this persistent storage, which we're going to do as JPA, is in an adapter. So we're going to put it in an adapter package. We already have a web adapter, but this is a different adapter. And so this will be, we can call it persistence, or we can call it JPA. So let's just call it JPA. If we come up with a better name, we'll use that. So we'll implement all these methods. Now, since this is going to be sorry, so this, I should have grabbed coffee during the break. I'll do that at the next break. So this is going to be an implementation that's going to be specific to Spring Data JPA. And this is almost a pure adapter. This is bridging the implementation between sort of our ideal transaction repository that we had defined in our domain and JPA and how it implements things. So what we want to do is we're going to need something injected. So this by itself is not good enough because we want to delegate it to something else. Let's go and create a new, well, it'll be an interface. Now we're going to have some fun with the naming. Let me think about the name for a second. Actually, let's do this. So this is the adapter. Let's actually call it the transaction repository JPA adapter. I know this is sort of a name where Java gets a bad rap for having long names, but basically this is the adapter part, right? So if we think about an adapter being this little tiny thing that connects between our domain and our repository, this is sort of the thing that bridges that. And that's exactly what an adapter does. It takes two things that aren't quite compatible and hooks them together. So that's one piece. That's the little adapter part. And now we need the implementation. And this is going to be a JPA transaction repository, but it's an interface. And this extends the JPA repository. The type that we're storing are transactions. I always seem to have trouble spelling that. And its identifier is long. We want our transaction. This is basically all we need, because at runtime, Spring Data will automatically do all the necessary code generation and stuff underneath to actually make this work with whatever database we've selected. So now we can take this, go into our adapter, and have it injected. So we'll do private final this JPA repository, and we will create a constructor. We'll auto wire it. So now for find all, we can do the JPA transaction repository find all. All right, so pure delegation. All we're doing is delegating it. Save, same thing. And save all. And that's it. So basically these two classes, this adapter class and then this interface. So this interface is sort of the implementation of connecting to the database. Sometimes you'll see people call these as DAOs. This thing is the adapter that's adapting JPA to what we need. This gets injected, right? So at runtime. And so now when we want an implementation of a transaction repository, we can just say repository. So now we have an implementation of our domain-specific and domain-only transaction repository that connects and uses JPA. So that way in our domain, account references transaction repository, which is an interface that has nothing to do with how things are stored, where they're stored, things like that. So we keep this separation, but we're not writing a lot of code. And so if I wanted to completely delete this adapter, this JPA adapter, and replace it with a Cosmos DB adapter that's used on Azure, which is something I have planned, then we can do that. And we'll see that when we get there. So now when we run the application, unless I've missed something, which is certainly possible, Spring will find an implementation of transaction repository that it can inject into account. Boom, Kit application is started. These are all the transactions that were loaded up from the database. So now we have an implementation that at runtime relies on Spring Data JPA, but our unit tests are still just running in the domain. We have nice separation between the domain and the persistence part. Oh, this is funny. Okay, I was wondering, it's like, what's going on here? There are some transactions in here that came from tests, and so we'll look at how to fix that, because that's not good. I was wondering why the account balance was weird. Application is running. We got our implementation for the JPA. It's sitting in its own adapter. Let's just take a quick look now at what we've got going with our code. So we've got our domain. It has three things. We've got an account, which is a holder of transactions and also does calculations of balance and handles deposits and spending. Transaction basically holds the information about each thing. So the date, what was done, the amount, where it came from. And the repository is our interface, and this is in our domain. So one thing, again, when you're trying to figure out, is this breaking our architecture? So our hexagonal architecture is really specific about separating things. And so we look at, are we referencing anything in here that looks specific to how we're storing it in a database? And it doesn't, because transaction, that's a domain object. Transaction, transaction. So there's nothing in here that is specific to any kind of database implementation. Then we can look at our JPA adapter, right? So here we've got this, and it's referencing JPA repository and Spring Data. That's fine. That's our adapter. This is sort of the true adapter part, and it's leveraging. So it's another implementation of the transaction repository. Let's go and commit. And so we have a implementation of transaction repository, Spring Data JPA implementation of transaction repository. Cool. Okay, so we're at the point, I think, where let's go to our Trello. So we have now separated transaction repository from the JPA implementation. Yay! Where are my sound effects when you need them? You need like a tooting horn. So now local Postgres running in Docker container, we'll get that in a minute. So we need, actually before we do that, or sort of these two together, is we need to have configuration for Postgres when it's running locally versus Postgres when it's running in container. This is actually a task. Let's make it such. And actually, we need to do this first. So we need a good Docker image for Postgres. Postgres Docker image. Yeah, that looks like the official one. Yep, that's a Docker official image. I think 11 is fine, or 11 Alpine. The Alpine ones tend to be smaller, I guess. Okay, so I got Docker running. Yes. So we'll do Docker. We'll pull the image first. The Docker one is, I guess, 11 Alpine. Oh, so this is interesting. I've been using Docker since 2013, so for a while, but then I actually stopped using it for a while too, and so at some point Docker Stack came to be as a thing, and I'll have to look into how to do that, because it looks like it's Docker Compose like using Stack, basically YAML, which I hate. I hate YAML. So I want to do a Docker pull Postgres. If we don't say anything, this will pull latest. In general, that's a super bad idea. If I just did latest, that would be bad. You never know what's going to happen, especially if you're going to do any kind of automated deployment. You never want to pull latest. So I think what we want to do is we want to just do, let's try 11-Alpine, see what happens. 11-Alpine. Let's see if we got that right. What do we need to run this thing? Okay, so I guess we can pass in the password. 5432 will be the standard port. Standard Postgres user. We can do a Docker run. We'll give it a name of KidBank Postgres. I don't care for locally, and so let's tell it the name of the image. Oh, dang it! Don't do that. All right, looks like Docker did something. Let's see. So it's running, and it's listening on port 5432. So basically our username is Postgres, and our password is pwd. So that's that part. Okay, so now we can go into our application properties. So previously we've been using H2, but now we want to use Postgres. So we will need to make sure we have that in our POM file. That's Flyway. So we'll get to Flyway at some point. So there's H2 and there's Postgres. So let's go here. Postgres is there. That's our runtime. Okay, as I said, I don't use Postgres very often, so what I need is the Spring Boot data source Postgres user password. Just a note, one of my sort of pet peeves is when people don't look at the documentation first and then ask about it. My preference is I go for primary sources, which are the documentation. And if the documentation doesn't answer the question, then I'll look elsewhere. But so what we have here, DB info, we'll look at what that is. We've got data source username, data source password. Okay, so let's grab this stuff and we'll comment these out for now because we're going to come back to one of the tasks here was to set up configuration for locally versus remote. My goal is actually to locally not use Postgres. That way I don't have to have it running. So locally I want to have H2, but then when it's deployed in production, I want it to use the Postgres that's running on Heroku. So let's pull this in. Let's get rid of that. Let's get rid of that. Let's get rid of those extra spaces. I love column mode. By the way, that was column selection mode, which is Shift Command 8. And that's where I can basically do edits on multiple lines at once. So you get these multiple cursors, and it's awesome. I love it. Okay, so we said the user was Postgres. The password was the genius PWD. That's our driver. The URL, I think, is the last thing we need. Spring data source URL. Right, so that's going to be JDBC Postgres, and I don't know what goes after here. My focus timer just told me that we are at the end of a Pomodoro of 25 minutes, but let's see if we can just get it to connect to the database, and then we'll take a break. The URL is basically that. So localhost 5432 is what the Docker container running Postgres is listening on. Let's give it a KidBank as the database name. Oh, may as well select the dialect. Sure. I'll have to do some research. I wonder what optimizations it's doing. Okay, so we connect it to PostgreSQL, localhost 5432. KidBank is the name of the database. We've got our username, password, the driver class name, and we've set it to update. I like this comment. I'm going to steal it. Should we run the application, see what happens? Let's do that. So now we should be connecting to the Postgres database. And since we have update, what it's going to do is it's going to see, hey, is there any schema there? No, there isn't. It will create then a schema table for transaction. Looks like we got a connection refused. So it is running. It is running on port 543. Oh, I wonder if that's not exposed. Because it's exposed, but I don't know if did I forget the E for, did I forget the ports? Yeah, so it's exposed for if I link it to another container, but I need to actually do it with a real port. Publish a container's port to the host. That's what we want. We want -P. Right, so it's -P. I wish they would give a simpler example. This is a pet peeve of mine, is like, hey, let's jump into the complex example where we're mapping multiple ports. Like, no. Please just give me the simplest example first. All right, so we're going to need to kill KidBank Postgres. Okay, and we're going to go back to our run. What we need is, not only do we need a name, but we need to publish the port 5432, 5432. We could try the -uppercase P, publish all exposed ports, and see where it randomly goes. Let's try that. Okay, well, okay, it selected a random port, which is 32768. I don't like the random port. I wanted to kill it and remove it at the same time, and I forget what force. Yeah, okay, so Docker RM, force it to kill the KidBank Postgres, because I want to relaunch it with the same IP address. Sorry, the same port. uppercase P truly does do random. So let's do this and 5432. So basically the format is IP host port container port. So IP host port container port. So those are just colon separated. Yes. Okay, good. So it mapped our local host 5432 to 5432. If we rerun our application, the database KidBank does not exist. Okay, so at least we got it connecting to the Postgres. So auth0, when we get to multi-tenant and authentication and authorization for different accounts, auth0 is one of the ones I'm gonna look at using. I think it's kind of funny that this example thing that they're using is question marks. I'm actually working on a survey tool that's specific to Java, because a lot of the existing survey form tools don't work well when you want to write code. So for example, the angle brackets around generics, they don't like that because they think that's HTML and they don't want HTML injected. Hey, look at that. We already did that. Did we specify Postgres _DB when we started it? Now I don't remember. Oh, no, we didn't. Well, that's why the database wasn't created. So the key part here is that we didn't specify the DB. Let's do that. Question is, what's the name of the database? Where do we specify that? Application properties. Oh, that's this part. Okay. So we specified that the name of our database was KidBank, except when we started up Postgres, we didn't actually specify that. So let's do that. Let's restart, remove it and kill it again, and then start it, and that's KidBank. Okay, so what we're doing is, this name is just the name of the Docker runtime container. This is mapping our ports so we can reach it. We saw that that works. This is the password. This is the name of the database. So let's do a Docker PS. So that's running, connected to the port. And now let's look at, so KidBank should exist now. Oh, looks like so close. Okay, so I saw something go by. Let's take a look. Method create clob is not yet implemented. Disabling contextual lob creation as create clob method through an error. I'm going to assume that that's not a problem. All right, well, let's see what happens. Okay, so let's connect to our app. So we expect no transactions because the database should have been empty. No transactions. No errors, so that's good. So let's go ahead and add a transaction, a deposit. That worked. No errors here. Let's clear out this console. Let's shrink it down. Let's try doing the bulk import. So let's go ahead and grab that from my clipboard. Paste that in here. Import. And boom, look at that. That's all in there. Okay, so let's shut down the application and we'll start it up again. So now we expect those transactions have been saved and they should be loaded upon startup. All right, it's all loaded. Let's refresh the page and look at that. And if you don't believe me that this was that, I can open up a new tab, go there, and there it is. Okay, so we now have our code working with Postgres. That wasn't too bad. Mistakes were made was I didn't have it initialized the database, but that was pretty easy to fix. So this configuration is for when I'm running it locally. What we want is a configuration for running it when we're launched on Heroku. So this is my Heroku Postgres database. One of the nice things is that I don't have to use any of these. Because one of the things about Spring in the way it loads configuration data is these properties, if they're not specified anywhere else, will be loaded from this properties file. But if you specify them on the command line, it will override these properties. So if you remember before, this is the command line, and here it's sending in a property to override server port. So server port here is a Spring Boot property that tells the embedded server what port to listen on. And at runtime, Heroku will fill this in from an environment variable. So when Heroku starts the application, it sets a bunch of environment variables, and this is pulling it in from there. So what we want is that we actually want to pull that information from the environment, right? We don't want to specify that in a config file, right? One of the things right, we really don't want any of our database credentials anywhere in our code or anywhere in our GitHub repository, right? That's just bad. I could view the credentials. I'm not going to do that. So now the question is how do I hook the two together? I'm assuming the database credentials are also available in the environment as environment variables, and so I just need to figure out what those are. Using the Spring, that's what we want. The official build packs for Java Gradle will attempt to create those environment variables when a dyno starts up. As long as your application has a proper JDBC driver defined as a dependency, these environment variables should allow, if you need to yeah, so we can basically pull these in from the environment variable. So the example they have here is using a YAML file. We're using just a straightforward properties file. I could convert to a YAML file. I don't want to do that. I hate YAML. So we actually have two options. One is, as you see up here, we can do the same thing like was being done for the server port, and we can just specify it in the proc file. I don't see the point in that. I actually want to put it in my priorities file. So I need to be reminded of how I pull in property information from the environment using a properties file. So it looks like the same thing. So it's the standard sort of $ curly brace thing. So great, okay. So I can just do that, come over here. We'll leave this, we'll leave these two because these are specific, don't matter. Yes, I know I'm commenting stuff out. I generally don't like to do that, but it's okay for temporary purposes. Let's go do that. Let's use the fancy this, insert. Have I said how much I love column selection mode? So now we specified Spring Data Source URL to pull this from the environment instead of having it manually specified. I think this will just work. The only question is somebody has to create the database, because when we started the Docker one, we specified the database to get created, but when we're running in Heroku, I don't know how we do that. Well, we could look at their sample project and see what they do. Samples are the best thing ever. What are the examples that they're doing? So what they do in their proc file. Okay, so they're creating the table. Oh, so this is creating tables. We don't want to create the tables. We want to create the database. So actually, this is the database, right? That's the service, but this is the database. So hold on. I'm going to view credentials because I want to see what this is, but I don't actually want you folks to see that. So hold on. Oh, I see. Okay. The database is going to be part of the URL. So it's giving me the URL from the command. Okay, so I think we're good, right? Because what happens is that this defines the name of the database. This full URL is sort of the path, port, and database. But since we're getting that from Heroku, we don't care about the name of the database. We're assuming that there's a database there. And then Spring Data JPA will create the tables and do its stuff. So, okay, so this should just work. So the only thing that's of concern right now is that these integration tests are not passing, because I haven't set up how to do that with the test data JPA. Kind of want to get this up on Heroku and worry about fixing these tests later. So what I'm going to do is ignore. So I'm going to ignore this integration test and this one. I hate to, in general, to leave ignores, but I'm not going to leave it for that long. So let's run all the so the reason why I'm doing this is because when I push to GitHub and then Heroku gets triggered to download that, it's going to run Maven to build it. But when it does that, actually to build and package it, to create the jar file, when it does that, it runs all the tests. If any of the tests fail, it won't deploy it. So I want to make sure all the tests pass so that it gets deployed. So let's run all the tests just to be sure. I think we're okay because I've ignored the ones that are broken. That one shouldn't have failed. Why did that one fail? So this is just sort of the most basic test of just making sure everything works, and clearly we've missed something. Oh, okay, because we are relying on database stuff. I wonder if this will magically fix it. So this annotation will disable full auto configuration, trial and error. If this doesn't work, I'm going to ignore this test too. Okay, let's ignore this test because I think there's other stuff I need to do to get this to work. So let's just ignore this, and now it should just sort of kind of pass because it's ignored. It's funny, it starts everything up and then basically ignores the tests, right? Oh, does ignore not? Oh, because I ran this test specifically. Okay, let's run all tests. Let's do that again. Wow, that was fast because it ignored all the integration tests. Cool. Let's just be doubly sure. Let's do a Maven package. So this is basically what Heroku does when it deploys the application, does a Maven package. Package build success. Awesome. Okay. Switch to Heroku. Switch to Postgres database running on Heroku. That looks good. That looks good. Commented out those tests. Right, we didn't really do much, right? We basically just had to figure out what the properties are. And then that was pretty much it. So we'll commit. And now we're going to push. So let's go over here and build in progress. Let's view the build in progress. Oh, so we didn't finish our tasks. So let's reward ourselves. Local Postgres running in Docker container. Check. Configuration for Postgres, local versus Heroku. I'm going to leave this here because we've sort of hard-coded it to only run on Heroku, and we want to have multiple configurations so that if it's running local, it'll use the right thing. If it's running in Heroku, it'll use the right thing. So we'll leave that there. Persistence for Postgres to use on Heroku. We're doing that now. Let's see what happens. Done, released, deployed. Look at that. The app is running. Let's go ahead and deposit some money. And look at that. So we now have, I have to say, like, when this stuff just works, I'm always pleasantly surprised because I always expect stuff to break. But we now have the application deployed on Heroku using the Postgres that's on Heroku. We can force it to, we can sort of force a change to show that even when it gets redeployed, that the database stuff is still there and we're reading it from there. I don't know, I'm convinced. So cool, we've got our database. Oh, actually we can look at the database. There are 10 connections. There are 10 connections because the default Spring Data stuff uses a thing called a Hikari connection pool. So it basically sets up 10 connections and uses those connections and reuses those connections as it needs it. There's one row, which was our deposit, and there's one table. And that's all good. So let's go back to our Trello board. So persistence to Postgres, yes, and it's running on Heroku. This will be some cleanup, but I think I'm going to call it a day here because we're persisting. So there's some cleanup with the configuration. There's also persistence and integration test cleanup. So those are just a couple of tasks. You can find me on Twitter, so at JitterTed on Twitter. You can also, my website's tedmyoung, and so I'm happy to get email. And the repo is here. Feel free to, if you have ideas or you see something, go ahead and file an issue. That would be cool. Otherwise, I'm going to keep working on it. So I've pushed the latest stuff. This is the stuff that's now running up on Heroku. But you can pretty much, it's really easy to deploy this. You can basically fork it and deploy it on your own. And so if you're learning this stuff, I really encourage you to do that. There is nothing, you can watch me do it, but there's really nothing like typing on the keyboard, struggling, searching. That is learning. When you're struggling and then you get it, you have learned it. So I really encourage that. All right, thanks.